Hey folks, Quilly18 here, and welcome to another Unity 3D tutorial. So this is part 2 of our TileMap series, and we are going to start this one by basically getting rid of everything that we made in the last video, and we're going to start fresh with a kind of a more proper mesh generation setup. So we are going to delete all of this, and we're going to delete these scripts here. I'll keep the tile mouse over around. We're going to have to change it, but that's okay. We're going to get rid of those. You'll see I've also imported a world map. This is from the NASA Blue Marble project, and they offer some really nice maps of the world. So I don't know why that took so long. All right. Oh, because I'm in play mode. Oh, that's not going to help. All right, delete. Good. Save. Excellent. So yeah, they put up some great maps, so you can just grab those, and we'll fiddle around with this a little bit more a little bit later. So what are we going to do? So we want to be able to create a map, a tile map, and we're going to do it programmatically, right? Procedurally. I'm going to create an empty, and I'm going to set it to 0, 0, 0, and I'm going to call this object TileMap. And then I'm going to create a script called TileMap, and I'm not going to forget to, come on, drag it over to my TileMap object. In fact, I'll make this a prefab just for good measure. So this is an empty object. It's empty. There's nothing that will show up on the screen, and so we have to populate it. So my TileMap script will be a relatively bare bones attempt at creating a simple mesh, a plain plane that we will use later to do some slightly more interesting things with. So we are going to, all right, well, let's create a few variables, and we'll make them publics, because why not? We will say public int, actually, here, we'll wait. So we want, when we start, we want to do something like build mesh. We will make this a function called build mesh. All right, and so on our object, this is going to be very similar if you watch my video about procedural road generation. There's going to be some of the similar sort of aspects we use to that. Now, if I create, just for a reference, let me bring in the other plane. So this is the existing plane. What is it made out of? Well, it's got a mesh collider, and it's got a mesh renderer on it. Now, the mesh renderer is particularly important. This is the thing that actually makes the object visible. I can toggle it this way. These green lines are the mesh renderer, or the mesh collider, you can see. So if this is off, you won't see anything. If the mesh collider is off, no one will run into it. It's just a visual object that everyone can sort of pass through in the game world. There's also an object called a mesh filter on here. Now, the mesh filter is responsible for actually holding our mesh data containing that sort of information. So we've got the actual mesh data, we've got the thing that says make this mesh visible, and then we've got the thing that says make the mesh collidable. Now, this doesn't actually operate on this mesh filter directly. It actually has a little placeholder for it, but we can sort of double up and use the same one, and it's going to work perfectly fine. So we're going to want the same sort of thing in our TileMap object. Now, we are going to start off with we need the mesh filter, that is for sure, mesh filter, because that's going to hold our mesh. And then we'll also put in the mesh renderer. There's actually more than one type of a renderer, but the mesh renderer is definitely the most common one. So we've got that. We'll also need a material at some point, but we'll get to that a little bit later. So our tile map has both of these, and I did this on the object instead of the prefab, so I'm going to apply that, which is another thing I tend to forget to do quite often. And so now we have access to the mesh filter, our own mesh filter. So we can cache that if we want. We may as well do that, and we're going to call it MF. And I think that we can, I'm surprised there's not a built-in mesh filter. There probably is, but what we can do is get component mesh filter. There we go. So we're going to get the mesh component filter on our thing. And what we could do is we could do a test here. If MF equals null, freak out, debug.log. Another good idea would be to go and say require component type of mesh filter. And I always get this syntax wrong the first time, so I apologize. There's probably going to need an extra set of braces. Parsing error. Is it like this? Or am I going to have to double check? Oh, looks like I got it right. Okay, excellent. So that is a different type of thing, the different type of check. So this check, if we check to see if MF equals to null, this is at runtime. When you run the script, it'll check to see if it's got it. But this will actually do the check at when you're building your object up. So we will actually do that. We'll do a mesh filter, a mesh renderer, and a mesh collider. We'll say we need all of those things. Otherwise, this just doesn't make any sense. And it's just a sanity check. So if I go over to my TileMap object, and I'll remove my script. Because right now, it's very happy to say, well, in fact, it doesn't have a collider on it at all. And if I hit play, I'm not going to get any message about it. Because I sort of, that check only happens when you're dropping a script onto an object. So let me remove the TileMap script from here. And now I will drag it back onto my TileMap. And my TileMap has a filter and a renderer, but it doesn't have a collider. And let's see what happens when I do that. TileMap on here. Burr. Really? Oh. Well, that's not going to help my example. Collider. So let's try that again. So I'm going to remove this script. And again, it seems to be pretty happy. It's going about, it's not throwing any errors, even though I don't have a collider. But if I remove this component, now when I add this, it will add the mesh collider for me. So these are just sort of sanity checks in the editor. So next time when you create this and you drag it onto an object, it'll make sure that it's got all the things that it needs. And that's nice and helpful. So, all right, so that's good. So, and then over here we've grabbed this, and we know now we can safely do this, and it's going to be fine. We might still, if you're sort of a belt and suspenders kind of guy, you might still want to double check that this is not null. But let's just go forward for this example. So the mesh filter, which is great. We're gonna grab an example of all of these. In fact, I'll use long names for clarity for this mesh renderer, so that no one comes back later and says, what's that Mr. variable? We'll do the same thing here. Mesh filter, and I guess we'll grab the mesh collider as well. Mesh collider equals get component mesh collider. And this might be the sort of thing you want to do in Start. If this build mesh is going to happen a lot, or you're going to modify the mesh a lot, you might want to cache it in some sort of class member variable. But we're going to be okay right here. So we don't even actually need any of this right now, because we have to build the mesh first. And so I'm going to actually shove this way, way, way down. The first thing we're going to do is build the mesh, and then we're going to apply it to the mesh filter. We're going to tell the mesh filter, well, here's your mesh. Have at it. So, all right, how do we build a mesh? Well, we'll need an actual mesh object to hold on to it. New mesh. So, and if you remember our procedural example, the mesh has a handful of things that have to be filled out. It needs a series of vertices. These are the points that make up a mesh. Every triangle is made up of 3 vertices, 3 points, and of course your mesh is made out of triangles. So we're going to have some sort of vertices that we're going to assign to it. And as I said, we have triangles. Okay, so we're going to have triangles at some point that we have to populate. And then we have mesh dot. Well, we're also going to need something called normals. We'll explain normals later if you haven't followed on. I think these are the only 3 things that we absolutely need at this point. So we, what are these things going to be? Well, actually, let me move this down here. So let me add some comments. We're going to create a new mesh. Then we're going to generate the mesh data. In fact, we don't even need this here. We're going to create the mesh data first. Then we're going to create the new mesh and populate it with the data. And then we're going to assign our mesh to our filter, renderer, collider. We don't actually assign it to the renderer, but let's pretend. So that's the order. So now we're at this step, and this is definitely the biggest step, is to actually generate the mesh data. So we need, first of all, we're going to need some data structures here to hold this stuff. Now vertices are points, and they are coordinates basically. In other words, they are vectors in this particular application. It's an array of vectors called vertices. New vector 3, and we need a size for this. we need a size for our array. And we are going to start, well, I guess we're going to use some variables for this. We're going to create, let's make this a public. We're going to say, actually for simplicity, let me backtrack one more time. We're just going to create a single square to start off with. Square has 4 points. Okay, that's fine. We are going to we need some triangles. Now triangles are simply, they just point to vertices. And so they just need to be integers. It's an array of integers. But in our particular example, we are going to have 2 triangles because we're making a square. So we're going to have, obviously, when you think about how a square is drawn, I need, maybe I need paint. Right? Let me get back in here. Do we have a brush selected? Right, so a square is one triangle and then another triangle. That makes a square-ish, sort of. Let's pretend. So our 2 triangles are going to point to a series of vertices. But the thing is, even though this is called triangles, this is not going to be, you might imagine that this is an array of 2. But it's not, because we actually need to contain the data for all 3. So this, the way it's going to work, this is going to be vertices number 0. This is going to be vertex number 1. And then we'll say 2, and then 3. And so our triangles, the triangle, let's call this one triangle number 1. Or triangle, yeah, all right. Triangle A, right? Triangle A is defined as the vertices 0, 3, 2. Sure, that's a 2. And then triangle B is 0, 1, 3. Now, one of the things you've noticed about my order here is on both of these I'm going clockwise, right? 0 to 3 to 2, that's a clockwise order. If I switch some of the numbers around, for example, let's cross that out, if I went 0 to 2 to 3, then we would be going in a counterclockwise order. And the reason this is important, I mentioned this in my procedural roads video, is these triangles are only rendered one way. Only one side of this triangle is ever rendered. So if you go through this process, and I tell you, there's going to be a 50-50 chance that I screw this up. If you get it the wrong way around, it's not going to be visible in the way that you want. It's going to be visible from the back side. So then you just flip a couple of these around and you get in a better shape. So we don't want a 2, we actually want a 6. Or another way to look at it is we have 2 triangles, and each triangle has 3 points. So we can do that. That's a fine way of doing it. And the normals, and again, I'll talk about it a little bit more in a little bit. We do need the normals, but in this application they're going to be very simple. Normals are also vector 3, and these actually represent a direction. Basically the direction going away from the surface. And again, if I do some sort of crappy art, you can imagine we've sort of got a plane here that we're looking at kind of from the side. Well, the surface, the normal, would stick out straight out of the top of the plane going this way. And in fact, it comes out, this is the surface normal, but it also comes out of each point, each vertex here has a normal that will face upwards. And the reason we need this data is because it helps to tell the engine how the light is supposed to hit it. This mostly becomes important when you've got, let's say we create kind of something that looks kind of like a tent, right, like this. And then I guess I can sort of, right. So we've got, imagine this sort of tent, right? It's made up of 2 triangles, or two squares, right, which is actually going to be 4 triangles. In this case, so you've got a couple ways of looking at it. This vertex here might go like this, or it's pretty clear that this is sort of normal direction for these vertices. But then the big question is what kind of normal direction you have there. Well, if this is actually supposed to be something kind of roundish, like right now I've drawn it as kind of a tent, but if maybe this is supposed to represent kind of a tube, right? But you can't actually do curves in 3D programs. So the best you can do is approximate it with a series of straight lines. And the more lines you use, the sort of smoother it will be. God, that is terrible. I can't draw with the mouse. Let's try vaguely more like that, right? So here I have used a series of 1, 2, 3, 4, 5 lines to approximate this curve. Well, in this case, there's two choices I can take with my normals. I can have a whole series of normals where I've got one that goes like this, and this one is like this, right? Well, this will make it look like it's sharp edges. It will make it look like it's facets, like a cut gem. Whereas instead, if I have the normal come out at kind of this angle, right? So it's I don't know, it's orthogonal to sort of both angles. I'm not sure what the right term to use here is. But what this will do is this will cause the renderer, the lighting, to smoothly shade across the surface. And this actually, I almost want to give, I should open up Blender, because this will give a good example if we go into Blender and I can really demonstrate what's what. So let's say I'm in Blender and I create an icosphere and I zoom in here. It should show up just fine here. Yeah. So you can see that this sphere is made up, it's like a gem, right? It's faceted. And that's because each one of these surfaces, each one of these points has the normals sort of perpendicular to the flat part of the surface. But if I tell it to do smooth shading, it's got exactly the same number of triangles. And you can see if I go into the wireframe mode, you can still see nothing has changed. If I go flat, smooth, nothing makes a difference here. But if I go back here, it's quite different. And that's exactly what the normals are there for. So depending on what you're trying to do, you're going to want slightly different normal behavior. Now, this does lead to a slight complication here, because if you want to do something smooth, then what you do is you have the triangle points. Let me go back to my paint masterpiece. Here, the triangle points will share the same vertices. This is vertex 0 and this is vertex 3. Well, each one of those vertices can only have the one normal, so this will inherently sort of be a smooth edge, right? Even if that's peaked kind of like a tent, this will still be smoothly rendered. But if you want a sharp edge for whatever reason, then you can't actually share the same vertices. In this case, what you would do is in the same place, we would have a vertex number 4 and a vertex number 5. So 3 and 5 are in the same place and 0 and 4 in the same place, but they have their own separate normals, because then we can get in a situation where we have a normal going there and another normal going there, which means that the dividing line here will be very sharp, just like our flat shaded sphere in Blender, right? Which is what's going on there. And that's totally fine, right? That's the same thing, except now our A and B are further changed in that A, let's call A 0, 3, 2, so I guess that one's unchanged, but B becomes 4, 1, 5. There we go. So that is something to keep in mind with the mesh. So are we making smooth terrain or sharp terrain is a big question mark. Let's go, just because it's a little simpler, we're going to go with smooth terrain, because then we need fewer vertices, fewer normals, and our triangles are a little simpler. So equals new vertex or vector 3, and we're going to use 4 as well. Now we're not going to want this to be hard-coded going forward, but for now it will be just fine. In fact, I don't really need these, do I? I'm just sort of being silly, unless I'm wrong. Yeah, I'm used to saying new and then the parentheses because it's a constructor, but here we don't have that. Here we're just initializing an array, and then what we're going to want to do is loop and actually initialize all of these. So for the first pass, I will do another hard coding pass. We're going to go vertices 0 is going to be at coordinates, so this is going to be a new vector 3. Why is this not working? What happened to my autocomplete? It's probably because I've got a syntax error somewhere. I know. We're going to set vector 0 at the 0, 0, 0 coordinate. Now, vertices 1. And which one is vertice 1? Let's go back to our drawing. Our vertice 1 is over here. So we're going to send it 1 unit over to the right, which is the positive x. New vector 3, 1, 0, 0. Vertices 2 is equal to new vector 3. I must have something screwed up, the fact that I'm getting these syntax errors. So number 2, we've decided is over this way. All right, that's fine. So that's at the 0x. It's 0y. There's no verticality to it. And it's going to be sort of towards us in the Z, which means a -1. Again, don't worry if you get this sort of direction wrong in terms of the signs. It just means one of your triangles will be facing the wrong way, in which case you can either flip the signs around or you can just change the order when we set up our triangles. And we're going to go number 3, which is going to be at the bottom right corner. Then we're going to set up our triangles. So triangles. Now triangles we don't have to create. Actually, we don't. Suppose I could have done this a different way. This should be okay. Probably. I don't know. I tend to make plenty of errors, but then I at least know how to fix them. Triangle 0 is going to be equal to. So this is our first triangle. We're about to define our first triangle, which is this trio, 0, 1, 2, and we have to give it a coordinate. So our first triangle is going to be A, and we know A is 0, 3, 2. So it's going to be 0, 3, 2. And then we're going to define our second triangle. So this is the next 3. And our next triangle is, well, it's actually going to be 0, 1, 3, because we're not using these numbers. That was for our sharp angles. So 0, 1, 3. All right, we've got our triangles. Now, what about our normals? Well, the normals are basically going to be the same thing as the vertices. Actually, I guess I should just grab the first line here. Right? Normals, new vector. Except in this particular scenario, we know that the normals are going to be pointing straight up. So we can actually shortcut it to vector 3 dot up. And that's perfectly fine. So in this particular example, this is going to work like so. And we can go over to Unity. And this actually won't quite work yet. No compiler errors, though. That's good. Because we create our mesh, and we assign everything to our mesh, but then in our, we've got to actually do some assignments here. Specifically, it's just mesh filter.mesh. We've got to set it to our mesh. And this should be enough to get started. This should make an ugly pink square. So we're going to hit play. We're going to see what happens. Boom! Wow. That worked shockingly well. We have an ugly pink square. Now, the reason it's an ugly pink square is because it doesn't have a material. So if we look here at our tile map and at our renderer, material, it's got none. So we're going to recreate a material. And it's going to be a diffuse material. And we could set the color, but instead, let's make it a little more interesting. Let's use this world map texture. Oh, let's rename this as well. We're going to call this Earth material. So we can just drag this material into the texture slot. And that's a decent start. And yeah, there's always weird pinching at the tops. There's ways to avoid that if we're actually making a round kind of map. But we're not. We're making a flat tile map. So now our tile map, we can take this material and assign it here. And there's plenty we could do to make this even better and fancier, but this is going to be plenty good for now. So now if I hit play, we won't get the ugly pink square. We do get something awfully grayish, though. Although, I'm amazed I did get the triangles the right way. So you can see the top renders, the bottom does not. So, why do we have an ugly gray square? Why don't we have a beautiful blue and green Earth? Well, the reason is we do not have any texture coordinates on our mesh. So, again, I've explained this a little bit in the past, but basically, what we have is we have a collection of these points. Now, let's go back to the beautiful paint thing. In fact, maybe we should start over. No, you don't need to save that. So we have our square like this, and we have, vertices in every corner. And then we have this bitmap. We have this texture. And the problem is, even though we, based on what this flat square is, we intuitively know how this bitmap should be applied to the square. But it's not really that simple to the computer's point of view, and specifically if we had a much more complicated map. Apparently, I'm assuming, again, we had a 3D model of a person, with arms and legs and face and nose and all these crevices and necks, and how do you take this flat map, because obviously all pictures are flat, how do you take a flat picture and apply it to a person? Well, you've kind of got to wrap it around or whatever. Well, maybe this part of the picture is supposed to be his face, and this part over here is his shirt, and his pants are sort of laid flat down this way, because you can do that. So how do you take that and apply it to the person? Well, every vertex in your texture map has something called this UV coordinate, and basically that defines a certain position here. So the tiles that make up the person's face will then be mapped to saying, well, this is the top right corner, and the nose part, this maps to this place sort of in the middle of this picture right over here, and the knee vertices map to these pixels on the image over here. So man, my drawing is amazing. So that's why we need these UV coordinates. Now, generating those for complex topography like a person is not something you do by hand. There's things you do in 3D programs to get those. But in our flat map here, it's actually very easy for us to create those coordinates, especially in this particular scenario where we've just got one square. So what we need is we need a new data structure to hold our UV coordinates. And our UV coordinates, and we can find this out on our mesh.uv. This is a 2D, there's a vector 2. It'll actually show me a completion here. I think my editor's a little bit messed up. So we need to create this. It's a vector 2, because it's two-dimensional coordinates called UV. We need a new vector 2. And how many of these do we need? Well, we need one for every vertice, or every vertex. Sorry, plurals. So we need 4 of these. All right, that's fine. We can totally do that. So we're going to do something. Again, we can sort of more or less copy this first one, I suppose, and then say UV, and then we can say it's a vector 2. So it's a vector 2. We only need 2 coordinates. So how do we map that? Well, again, in our case, it's pretty simple. We want this coordinate to map to the 0, 0 point on the graphic, right? This is point 0, 0. This is point. Well, if we were looking at a bitmap, like my bitmap here, the actual raw file is quite large. It's 5400 by 2700, but it's actually getting shrunk down a little bit in Unity to a max size of 1024 just for efficiency. It'll make a smaller download and use up less RAM and all that kind of good stuff. But still, we don't want to say 0 to 1024 and then later on we go and decide, oh, you know what, we've got enough RAM, we can make this bigger, we can make this a 248, so then we change the numbers. No, it doesn't work that way. This rightmost point is 1-0. This ranges from 0 to 1 this way and 0 to 1 this way. It's a floating point number. So the extreme bottom right will be the 1, 1 point. Okay, well that makes it pretty simple. So the top left corner. So again, vertice 0. This is 0, 1, 2, 3. In how we arranged it. I mean, depending on how you build it, you could have it go 0, 1, 2, 3 that way. That's perfectly fine. But the way we have it, we have 0, 1, 2, 3. So 0 is at the 0, 0. The 1 is in the top right, which is going to be 1, 0. The 2 is at the bottom left, which is going to be 0, 1. And the 3 is at the bottom right, which is 0, 0 like that. So now we've assigned UVs, still getting set to the mesh. So now, if I stop the program running, stop, and then start again, now we have UV coordinates. Fortunately, we've put them in upside down. And you're going to say, well, why is it upside down? Well, the reason, because it's like, well, I followed that map. This should work. The reason is that and this partially depends on what program you're using and a variety of little internal things. For these 2D textures, these 2D bitmaps, Unity actually says that the bottom left is the 0, 0 coordinate. So this is 0, 0. This would be 1, 0. This is 0, 1. And this is 1, 1. So I have to change this around to, well, basically I just have to flip these guys around this way. And now if I stop and start, this works there. Obviously, the other alternative is I could take the camera and turn it to the other side of the screen. It's like, well, yeah, what's upside down? What if I take this thing and then I rotate it 180 degrees? Like there's all kinds of things. What is right side up? What is right side down? The enemy gate is down. There's some some Ender's Game references to you guys. So it's a matter of perspective. But I've decided that this is my master orientation. Things should face this way, so that's the way it's going to work, by golly. So we can actually zoom in. Even though this is a 1x1 square, we can zoom in quite a bit and still get that. We can actually zoom in as far as we can up until the texture or the camera clipping point. And I could change the camera clipping point to be able to see even further there. So that's great for one square. But obviously one square will not do because we want to be able to, well, a few different things. Actually, if our world was literally supposed to be 100% flat, one square would be fine. We'd probably make it bigger, either by changing these coordinates, and we could just add a couple of zeros on this, right? So now we've got a plane that's 100 by 100. I can stop and play. Now it's much, much, much bigger. Everything else about it is exactly the same, right? Same proportions. If we zoom out enough, you can't tell the difference between this and the previous version. But maybe for whatever reason you've decided by 100 and 100 is perfect. Obviously, it should probably be a little bit longer. So I mean, we can go back and we can change these sizes here, and then that's definitely an option. If your game map is literally okay being perfectly straight, you can have it just be a single, like we have two triangles. Our entire map with this beautiful earth on it is exactly two triangles, two polygons. So how's that for render speed? In fact, except for the fact that it's probably yeah, I think it's got VSync on, or maybe it's because of my recording. This render speed should be like nigh infinite at this point, just ridiculous amount of frames per second. And yeah, and that's fine. And you're going to say, well, how do I tell which tile? Because I'm still playing with a tile-based game. Well, that's okay. When you do your collision detection, when you do your raycast, one of the things you're going to get out of it is a coordinate of exactly where your mouse is. So it'll return and say, oh, your mouse is on this, it's at 27 by 58 this way. So you're going to know, well, okay, I'm on my tile 2758, even though graphically it's just a single flat plane. But if you want bumps and blips and that sort of thing, you want mountains and you want deep oceans, then this will not cut it because we're going to want elevation data. So we are going to want to subdivide this into many, many squares, which means this sort of brute force approach is going to be no good at all, especially since you don't want to hard code in this data. You want to have all kinds of random generation. So that's going to be our next video. See you next time, folks. Bye-bye.